This is the vocabulary for lesson 6-4, and our first word is percent of change. And the definition is a ratio that compares the change in quantity to the original amount. My examples to go along with it, I have a formula. The percent of change is equal to the amount of change divided by the original amount. And then I have an example that was taken from the book, which shows us how to find the percent of change if it went from 60 degrees Fahrenheit to 84 degrees Fahrenheit. So there's an example to go along with that. We'll talk more when we get into the lesson. And then our percent of error is the measure of the difference between an estimate, prediction, or a measurement and the actual value. Formula is the percent of error is equal to the amount of error divided by the actual value. Take the absolute value and multiply by 100. And again, I have an example over here, finding the difference, taking the absolute value, dividing it by the actual value to give you your percent of error. Notes 6-4 on percent of change. We're going to find the percent of increase and decrease and find the percent of error. The Common Core state standards are listed and the mathematical practices. So the first thing that we're going to do in section 1 is look at the percent of change. It's your formula, and that's the amount of change divided by the original amount, multiplied by 100, and you get your percent of change. Here are some keywords to look for. You would actually take your new amount, which we can call n, minus the old amount divided by the old amount. So you have to do everything in the numerator first, divide, multiply it by 100, and that gives you your percent of change. The percent of increase is when the percent is positive. The percent of decrease is when your percent is negative. So find the percent of change, round to the nearest tenth if necessary. So we have a Discman here. It's something that was popular back in the 90s, and it was probably around $75 then, but now we don't have Discmans. You can't find them anymore. No one wants them anymore, so the price is reduced down to about $30. So start by writing down the formula, and the from is your old amount, the to is your new amount. So substitute into your equation. The new amount is $30 minus the old amount, which is $75, and we're going to divide that by 75. We have to multiply that by 100. So first do your subtraction. So we get negative 45 divided by 75, multiply that by 100. Using your calculator, negative 45 divided by 75 gives you negative 6/10 times 100. When we multiply it by 100, it moves our decimal 2 places to the right. This is converting your decimal into a percent, so it's negative 60%. Since it's a negative, this is a percent of decrease. Number 2, from 16 inches to 22 inches. So this example could be used when we're comparing snow from last year to this year. So the old would be the 16 inches, the new would be the 22 inches. Copy down the formula. So substitute into the formula. The new is 22 minus the old is 16, and we put that over 16. Multiply by 100. 22 minus 16 is 6 over 16. Times it by 100. Divide 6 by 16 in your calculator, and you get 0.375 multiplied by 100, which when you multiply by 100, it moves your decimal over 2 places to the right, so we get 37.5%. Since it's a positive, this is a percent of increase. That means that from last year to this year, our price went up 37.5%. This means that the amount of snow from last year to this year went up 37.5%. All right, from 525 pounds to 230 pounds. So this is our old 525, our new is 230. So it's 230 minus the old, which is 525, divide by the old 525, and then multiply it by 100. 230 minus 525 gives you a negative 295. So we can see because it's negative, it's going to be a decrease. Divide that by 525. multiply it by 100. When we divide negative 295 by 525, we get negative 0.5619. You don't need to write any more places down. And we're going to multiply that by 100. So bring your decimal over 2 places to the right. So it gives us negative 56.19, which we now have to round to 1 place after the decimal. So the 9 tells us we need to change that 1 to a 2. So negative 56.2%. So this means that the person's weight dropped from 525 down to 230. So it is a percent of decrease. And it means that they dropped 56.2% of their body weight. In 1975, the average price of gas per gallon was 57 cents. In 2000, the average price of gas per gallon was $1.47. What is the percent of increase? So the 57 cents is your old amount. The new amount is $1.47. So it's $1.47 minus 57 cents divided by 57 cents times 100. Subtract, and you get 0.9 or 0.90. Divide by 0.57 times 100. And when we multiply, and I'm just going to put it off to the side here because I'm running out of space, we get 1.5789. Just have 4 places after your decimal. We're going to multiply that by 100. When you multiply it by 100, it moves your decimal 2 places to the right. So we have 157, but we need to round it to the 10th spot. So the 9 tells us to make that 8 a 9. So it's 157.9%. And that is a percent of increase. This means that the price of gas went up 157.9% from 1975 to 2000. Section 2, percent of error. The formula is the amount of error divided by the actual value. Take the absolute value of it, multiply by 100, and that gives you the percent of error. The keywords: you take your estimate minus your actual, divide by the actual, take the absolute value of it, because it's non-negative, multiply by 100, and it gives you your percent of error. Find the percent of error, round to the nearest tenth if necessary. Number 1. Alyssa estimates that her school auditorium has 660 seats. It actually has 750 seats. What is the percent of error of her estimate? So we're going to take the information and we're going to put it into the formula. So she estimates that it has 660 seats, and it actually has 750. So we are going to take the estimate, which is 660, minus the actual, 750, divide it by the 750, and we're going to take the absolute value of it. Multiply that by 100, that'll give you a percent of error. We can use a calculator to subtract, and when we subtract, we get negative 90. Put it in your absolute value, and we're going to divide by 750. Multiply it by 100. Take the absolute value of the negative 90, so that is 90 divided by 750 times 100. 90 divided by 750 gives you 0.12 times 100. When you multiply by 100, it moves your decimal 2 places to the right. So that is 12. Add your percent sign, 12% error. Number 2, baby's estimated weight is 8 pounds. The actual weight is 6.4 pounds. So we want to find out the percent of error. We take the estimated, which is 8 pounds, and we're going to subtract the actual, which is 6.4 pounds, and divide it by 6.4. Don't forget to take the absolute value, and we'll multiply it by 100. When we subtract 8 minus 6.4, we get negative 1.6. Divide
divide by 6.4, we have to take the absolute value, multiply it by 100.
We take the absolute value of negative 1.6. It's a positive 1.6.
Divide that by 6.4, multiply by 100. We get 0.25. Multiply that by 100, which brings your decimal over 2 places to the right. So it's 25% error.
Number 3. The caterpillar measured a length of 2.5 centimeters. Its actual length is 2.54 centimeters.
So we take our estimated, which is 2.5, minus the actual, 2.54, divide by the actual, 2.54, and take the absolute value, and we also want to multiply by 100. When we subtract, we get negative 0.04 divided by 2.44, and we're going to take the absolute value and multiply by 100. Take the absolute value, so it's 0.04 over 2.54, multiply that by 100.
Divide 0.04 by 2.54.
And we get 0.0157. We're going to multiply that by 100. We only need to write down 4 places. When we multiply by 100, it moves your decimal 2 places to the right. So it's 1.57, but the directions do say round to the nearest tenth. So it would be 1.6% error.